This is Dragonfly, the first multi-rotor vehicle from NASA that will ever set foot, ski, on another planet. Part robot, part space drone, Dragonfly will make the 759,000-mile, 8-year journey to Titan, Saturn's largest moon. Rivers, lakes, and seas across its surface are filled with not water, but liquid methane and ethane. During a 2.5-year mission, the rotorcraft will land in the Shangri-La dune fields and make its way to the Selk impact crater, where scientists believe the ingredients for the recipe for life once existed. Dragonfly will focus on both in order to better understand the origin of life in the universe. It's set to launch in 2026, but won't arrive until 2034. The ice worm could be the name of a terrible superhero, but in this case, it's a little squiggly robot. It's derived from a single lemur limb, and it moves by scrunching and unscrunching, just like an inchworm. It's part of a family of projects in development to explore Saturn's and Jupiter's icy moons. The worm drills into the ice, end over end, in order to climb or stabilize itself while collecting samples. It also inherited its mama's AI, which helps it navigate by learning from past slip-ups. Arguably the most famous robot on its way to Mars is the Mars 2020 rover. It's about the size of a car, 10 feet long, 7 feet tall, and 2,314 pounds of pure robot. It's based on Curiosity, the NASA rover that landed on Mars in 2012. Relying on a proven system cuts down on costs and risks. The new rover will continue to search for past and present habitable conditions and signs of life. But it's bringing to the table a new drill that can bore holes in the surface and store the soil and rock samples for later use. But inside the Mars rover will be a little Moxie, or the Mars Oxygen In Situ Resource Utilization Experiment. Its job is to prove it can make oxygen on Mars for fuel and breathing, like a happy little robot plant. Mars' atmosphere is made up of about 96% carbon dioxide. No good for humans. This car battery-sized version of Moxie will only be able to produce about 10 grams of oxygen per hour. Future oxygen generators will need to be about 100 times larger for manned missions.